Welcome again for the panel discussion. Shishandu Mukherjee is a well-known name. He is the convener of this one. I'll give a very brief about Mr. Mukherjee. He is graduated from IIEST Shibpur in electrical engineering and also completed postgraduate diploma in quality management from Mahindra Institute of Quality. He has over 26 years of experience in mining, ferroalloys, production, sales, total quality management, and also worked in business analysis group. He represents Tata Steel in IMNI and also vice chairman of Indian Ferroalloys Producers Association. He is currently working as the chief operation in Ferroalloys and Mineral Division. With this brief, may I request Mr. Mukherjee to conduct this, please. Thank you.
So good morning, everyone. I think still there are a couple of people maybe outside, but I think I would start with, there's a lot of insight we got in the first session. Okay, so and we will take our discussion forward from there. But for all of us, India is a developing nation, and as I know, we started with mining. I think mining is terms of, for steel it is iron ore and manganese ore and other raw materials. And if you move one step up, it will be ferroalloys, and is obviously the final end product is steel. So we start with Mr. Deepak Agrawal, because he represents the steel industry as far as in this dais. So I think government has very ambitious target of doing some 300 million tons of steel by 2030, where I think we have heard Mr. D.V. Sundaramam talking about, I think 210, 220, which looks more reasonable, I would say. At the same time, there are challenges around infrastructure, that if you have to produce that much of steel, you have to move that much of raw material from mines to different plants, ports. So as an industry point of view, and everything is connected with sustainability, I must admit that, because if you move something by road, we are sort of diesel, petrol, gas, whatever, we are, that's something that we are consuming, and that also creates pollution in some sense. So therefore, and there is a talk also going about the slurry pipeline for a longer period now, and then there is not a very clear-cut policy guideline that how the land will be allocated, how this entire journey would happen, because the policy is not about a slurry pipeline. How to make it happen is also a big point. And third, I think bigger point is, since we have to move some 250 to 300 million tons of iron ore today, maybe which will move up to 400 million tons by 2030. So there is not enough railway network also, or enough railway rakes that is required to move those materials. So how does the industry look at it, and what are the real challenges for the industry if you have to move to a 220, 230 million tons of steel? Deepak ji.
थैंक यू. मेरे को ये अपॉर्चुनिटी मिली कि मैं इसके अंदर में अपने विचार को रख पाऊँ. जैसा कि इन्होंने बता ही दिया कि क्या क्या चैलेंजेस हैं. आज वो 130 मिलियन टन स्टील का उत्पादन करने के लिए स्लरी पाइपलाइन जो इंफ्रास्ट्रक्चर का एक पार्ट है, रेलवे की रैक्स जो कि हमें नहीं मिल पाती है, बहुत प्रॉब्लम हो रही है. गवर्नमेंट एक तरह बोल रही है कि हमें प्रोडक्शन बढ़ाना है, तो ये लॉजिस्टिक की बहुत बड़ी समस्या है. उसका स्लरी पाइपलाइन अगर हम लोग कर दें तो ROW की समस्या आती है, जिसकी ज़मीन है वो करने नहीं देते हैं. तो गवर्नमेंट को कोई स्पेशल जो है इसके लिए कोई पॉलिसी फ्रेमिंग करनी पड़ेगी, जो कि हम लोग इसका लाभ उठा के जो इंफ्रास्ट्रक्चर को जो है मजबूत कर सकें और गवर्नमेंट का जो टारगेट को हम लोग अचीव कर सकें. दूसरा, पोर्ट के अंदर में जो जहाज आते हैं, सिर्फ की लोडिंग अनलोडिंग को बड़ा फास्ट करना पड़ेगा, सो दैट कि हम लोग अपने टारगेट को हम लोग अचीव कर लें. ये सारे चीज़ जब सिंक्रोनाइज हो जाएंगी तो करना पड़ेगा. दूसरा, हमें ये देखना पड़ेगा कि आज हम ग्रीन एनर्जी की बात कर रहे हैं, ग्रीन स्टील बना रहे हैं, ग्रीन एनर्जी की बात करें, पोल्यूशन को कम करना है, बहुत अच्छी बात है, कम करना है, लेकिन इसके लिए जो कॉस्ट आएंगे तो उससे हमारा स्टील महंगा बनेगा. तो गवर्नमेंट अगर हमें इसमें सहायता करे, कुछ सब्सिडी देगा, इंटरेस्ट में सब्सिडी देके, या और कोई तरीके को कुछ सब्सिडी देगा जिससे हमारा कॉस्ट ऑफ प्रोडक्शन कम हो जाए, तो हम गिरनी स्टील के बारे में सोच सकते हैं, क्योंकि सबसे बड़ी समस्या आज ये लेकर के कि अगर हम स्टील का प्रोडक्शन बढ़ाते हैं तो 3 टन जो है मटेरियल में हमारा 1 टन स्टील बनता है। तो ये जो हमारा वेस्ट प्रोडक्ट है, ये जो हमारा ये फॉसिल एनर्जी के कारण जो हमारा पॉल्यूशन होता है, उसको भी हमको ओवरकम करना है, क्योंकि दोनों को बैलेंस करके चलने से ही जो है समाज का कल्याण हो सकता है। सिर्फ हम प्रोडक्शन बढ़ाने की बात करें और पॉल्यूशन कंट्रोल नहीं करें तो ये भी बहुत दिक्कत होगी। तो गवर्नमेंट ही हमें सपोर्ट करेगी तो जाके हम लोग इसके बारे में सोच सकते हैं।
सो एक फॉलोअप पॉइंट है इसमें दीपक जी की ग्लोबल स्टील मार्केट के अंदर में काफी वोलेटिलिटी है, काफी वोलेटिलिटी था, अभी भी है। सो गवर्नमेंट हैज initiated some actions on protecting at least some HR coils or some of the products, not everything. But ये जो challenges है, so ये industry के जो challenges है on volatility on the prices and export के ऊपर भी काफी pressure है। हम सब जानते हैं चाइना के अंदर में करीब करीब 100 million स्टील चाइना बाकी देशों में एक्सपोर्ट कर रहा है। So Indian industry के point of view से how do you think that this price stability will come in a short span of time, or how that industry will react जो globally जो हो रहा है, तो उसका आपका क्या विचार है?
क्वेश्चन, हमें स्टील का कॉस्ट ऑफ प्रोडक्शन कम करना पड़ेगा और स्टील की गुणवत्ता जो है को अच्छा बनाना पड़ेगा, और डिफरेंट मार्केट के अंदर में हमें जो है अपने माल को सप्लाई करना पड़ेगा कि अगर एक मार्केट डिस्टर्ब होता है दूसरे मार्केट में हम स्टील का प्रोडक्शन कर पाएँ, सेल्स कर पाएँ, जिससे कि हमारा प्रोडक्शन कंटिन्यू रहे। अगर इस चीज़ों में हम लोग ध्यान देंगे तो हम अपने टारगेट को भी अचीव कर पाएंगे और अपना प्रोडक्शन भी जो है वो हमें कम नहीं करना पड़ेगा।
थैंक यू। सो मैम, since NMDC is the largest iron ore producers in the country, I think obviously there's a lot of responsibility also lies with NMDC. So sustainability I'll come later, but we just wanted to understand from NMDC's perspective, if government of India is talking about 300 million tons and we are talking 210, 220, so NMDC is probably doing some more than 40 million tons now. So how do you look at NMDC's production plan going forward? And obviously NMDC also have own steel mills now, NMDC Steel. And I understood that NMDC is also going to have some supply linkage with RINL also. So how do you foresee the demand going forward for India, and how NMDC is going to supply iron ore to different producers of the country?
Morning all. This is Shanti Venkateshan. I represent NMDC, the largest iron ore producer in the country. I bring with me the regards and accolades from our dynamic Chairman, Mr. Amita Mukherjee, and the Director Commercial, Mr. Suresh. Because they are engaged in Mumbai conference, they could not be present here. Otherwise, the aura of their presence would have been very different here. Why I am taking the name of my chairman is he is the face of the company who has been, he in every forum wherever he goes, he has given this logo for NMDC that we are a responsible, sustainable, scientific miners spreading smiles across the world. This is the tagline, and it is not that easy to take this tagline always with you. As Mr. Sirsendu has asked, yes, definitely the challenge is very huge to support the steel policy. The pressure on NMDC is such that what we have achieved in 60 years, like overall, from 0 to 45 million tons has to be achieved by us in the next 5 years, that is by 2030. We have fixed a harsh target for ourselves, that is achieving 100 million tons by 2030. This may look very impossible, but again, the team is geared up, technology is there with us, consultants are there, and since NMDC has its own steel plant now, we understand the pain points of the steel industry. We are geared up for that, and since when sustainability questions are coming up, I'll definitely give the input of what NMDC is doing. The commercial strategy, the robust evacuation system, and very soon you will all be looking NMDC as a major iron ore miner having mega blending yards for which preparations are already on, which will definitely assure the quality what we say that we deliver. And in the course of the discussion, I will be discussing more of that. Thank you, Sir.
So, on a follow-up point, ma'am, so when you say sustainability of NMDC, so sustainability in terms of mining operations, you know, since you are the largest miner in the country, and also the product, because you are still looking at iron ore as a product, or are you thinking, you know, some agglomerates? That's something that you will serve the customers. Because in some sense, you transport less, you pollute less. You beneficiate more, or you improve the quality, you also pollute less. So how do you look at NMDC going forward, being not an iron ore supplier as a organization, but as a probably little value-added supplier to the customers? So is there any plan like that in NMDC?
As the need of steel industry for sustainability, and when we talk about electric arc furnace, DRI process, you look for high-grade ore. And since our mines are very old and gone very deep, the low-grade fines are also generated. Keeping this in mind and to support the steel industry, we are coming up with beneficiation plans. 2 beneficiation plans are planned from our Baladela area. Of course, coming to pellets, we already have a pellet plant at Karnataka, 1.2 million ton. And beside our steel plant itself, we are coming up with a 6 million ton pellet plant. So as you said, NMDC is moving ahead from being iron ore miner to giving value added products. I think I have made the point.
Thank you, ma'am. So I'll move to Naveen ji. I think if you look at overall India's perspective, you know, when you talk about iron ore, steel, ferroalloys, as Deepak ji was also mentioning that, you know, value-added products. So whatever India is doing today, and if you have to be sustainable in terms of environmental parameters, sustainability also in terms of your cost parameters. So based on your rich experience for so many years and, you know, being involved in many organizations, how do you think that Indian industry would be sustainable going forward?
When we talk about sustainability, we can differentiate into 2 ways. One, it can be product-wise, other, it can be industry-wise. When we go product-wise and we talk of raw material, so this we have to ascertain that raw material is something which is very natural. If you want to put up a steel plant, you can make a steel plant anywhere. But if you want to have a raw material base, it's a natural thing. Another thing, when you are talking about product, every product has a life cycle. So to be sustainable, what the topic of our seminar is sustainability of Indian steel and ferroalloys industry, challenges and opportunity. So you have to understand the product life cycle. I'll give you a small example. As to, we always compare ourselves with China. Somehow I think we should have a benchmark with world's number 1 country, not world's number 2 country. Now I'll give you a very small example of how ferroalloy manufacturers in China make themselves sustainable. They use the jugaad technology. Jugaad is a word in Hindi word which is now part of the dictionary, Oxford Dictionary. Now, when we start, let us say, we start manufacturing ferrosilicon. So we make a plant, a small plant, big plant. We put stress on safety. But in China, all they have to do is have a crude furnace and they start making ferroalloys. So my point is, what is the kind of sustainability you are looking at?
Unfortunately, safety, I'm a little bit from a Tata Steel perspective, I say, I think we cannot produce ferroalloys in any way. I think I will not compare with China in some sense, but I think it's more about what is the best technology and how do you utilize the raw material most efficient way. So therefore, I'll come to Binodji. I think he's in true sense is an innovator, I would say, because I know him for more than 20 years now. I think he has done a lot of work in terms of sustainability also, and he would give us a perspective that, as I said, there is a coke, there is a coal, there is a coke fine, so everything is available to the world. But how do you utilize which is more cost effective and in the best? I think the technology also plays a very important role. So which I think India, we are gradually catching up to the rest of the world. But the bigger challenge for all of us, what is available today with us, are we utilizing the best way? So Binodji can throw some light on the technological intervention that he has seen in last 2 or 3 decades. Over to Binodji.
Thank you, Sri Sandhu sir, and good morning to all of you. It's an opportunity for me to interact with all of you on a very, very pertinent subject like energy, coal, metal manufacturing. And all these things we are looking in terms of either comparing with China or comparing with possibly whatever technologies are available in the books. Can we not look beyond all these books, beyond all this, whatever is being discussed? Like today the world is talking, if we go to other industries in terms of nano, we know that there are only 2 reductants. हमारे पास में 2 ही reductant है, either hydrogen or carbon. We can reduce iron or other alloys only with these 2. But have we ever thought that whatever the science says, are we near to the scientific figures or we are much beyond that? Like to produce 1 ton of molten metal, you need about 225 units of carbon theoretically. But are we near to that? Anywhere near to that? Possibly no. Then the answer lies in how we can utilize this carbon either by activating it or by converting it to nanoform or by increasing the surface area of it, which will be more reactive, or maybe creating an in situ reaction. We are basically followers. यहाँ पे ये हो गया, somebody has done in Korea, we will see it, we will try to do it in a small way. But are we really spending on the real time R&D? We try to be followers. कि किसी ने किया, successful हुआ, we will try to follow that. But if we think beyond this, then possibly it is possible that to produce steel with those kind of carbon figures, you can use both carbon as well as hydrogen, both the things together, because there is hydrogen embedded in coal also, and at a particular temperature it is extracted. Now you have to only design your product mix in such a way that you use hydrogen at that particular temperature. Like for example, I'll give an example of a material which is not being used much in ferroalloys, but some people are using anthracite coal in a ferroalloys furnace. Now anthracite, if you see, it is the worst kind of carbon to use in a metallurgical industry, only because it has got a very low reactivity. But when you talk of carbons, then it comes at the top of the table. Anthracite ABCLP, we rate it as the best carbon available. But have we ever thought of utilizing this kind of a carbon? Possibly no. If we make it reactive at a lower temperature, possibly it can work like a coke. It has got that kind of CSR, it can work in a ferroalloy furnace. And then hydrogen can be released, possibly at a temperature of 970, which is a sweet zone. We are not thinking of that. In a ferroalloy furnace, have we ever talked of zoning of the furnace in terms of temperature profile of the furnace? We talk of very good efficient furnaces. But about the temperature profile, very few people talk. The sweet temperature profile is 600 to 1200, within which lot of reactions can take place and lot of pre-reductions can be done, which will reduce the load when you are really smelting the metal. At that time, you can have very less energy input, and that is what will be sustainability. Same thing we can think in terms of iron ore, and same thing in case of any metallurgy. I'll take 2 minutes more to explain, sir. The finer material, what Dr. Bhattacharya was saying here, that chrome ore overburdens and chrome ore whatever is lying there. We did an experiment in our laboratory in an induction furnace by a flash reduction process, melting this material, and we found, as Dr. Bhattacharya said rightly, that there are traces of cobalt. We could get up to 0.11 cobalt. We could get moly. We could get nickel in that, about 0.15. So all these noble minerals are available. Only thing is at what level and in what way to do. This is what we have to do.
I think you spoke a lot about what is to be done. So coming back to Deepakji once again, so Indian steel industry, whatever we are doing or whatever we have done so far, and whatever we are going to do in the future. So what do you think that from a technology point of view, whether we do DRI, whatever we are doing, can we do it in a more cost effective way, more environmental friendly way and more sustainable way? Usme, what is your view? How can we do it?
गुड क्वेश्चन. इसमें हम लोग पॉल्यूशन को भी कम कर सकते हैं और कॉस्ट ऑफ प्रोडक्शन को भी कम कर सकते हैं अगर इसमें टेक्नोलॉजी अपग्रेड किया जाए. जैसे DRI के अंदर में कोल को अगर यूज़ नहीं करके अगर गैस पे किया जाए, गैस का सस्ती गैस मिल जाए और गैस को यूज़ किया जाए तो क्वालिटी भी अच्छी बनेगी और पॉल्यूशन भी नहीं होगा, कॉस्ट ऑफ प्रोडक्शन भी कम होगा. इस टाइप से नई टेक्नोलॉजी को जो है हम लोग इसके अंदर में अप्लाई करके कॉस्ट ऑफ प्रोडक्शन को कम कर सकते हैं. टेक्नोलॉजी सारा खेल जो है टेक्नोलॉजी बेस ही है और प्रोडक्शन को अगर हम ज़्यादा से ज़्यादा करें तो कॉस्ट ऑफ प्रोडक्शन को भी कम कर सकते हैं और अच्छे मार्केट को हम लोग कैप्चर करें सो दैट कि जो हम प्रोडक्शन कर रहे हैं उसको हम सेल भी कर सकें. थैंक यू.
तो नवीन जी, जो आप बोल रहे थे प्रोडक्ट लाइफ साइकिल एंड प्रोडक्ट के बारे में, सो माय अगेन पॉइंट वुड बी, if you look at the ferroalloy industry, I'm stepping back from steel, ferroalloy industry, now we have not done much technological upgradation as far as Indian industry is concerned. If you look at globally, I think Premas technology is the last thing that somebody has done in a chrome furnace. It is mostly a pre-reduction technology where your power consumption is 40% lower. Your carbon consumption, not carbon, coke consumption is hardly not there. It's purely coal-based technology. So, what according to you, from an Indian ferroalloy industry, that some 2-3 things that we should try to make it more innovative and more sustainable?
See, R&D is one of the most important thing, and it is the backbone of either ferroalloy or steel, you say. For R&D, India is not very advanced, but we can join hand with countries like China, USA, and also have our own R&D areas. And once we do research and development, that will help us to mitigate the risk factors and have excellent products. Once you have a product, you will get a premium from wherever you sell the material, and you will have a market. And once you have the product and the quality, market is all yours.
Okay, thank you. So, ma'am, I think coming back to again the point of, you started with that you are targeting about 100 million ton of iron ore production maybe by 2030 or maybe little more than 2030. As you rightly mentioned that, you are looking at beneficiation, pelletization, which are probably the next big thing for the industry. But is there something that NMDC is trying to do? Again, I think the question I have probably have raised earlier also, in terms of mining technology, that, if we can improve the way we are mining, maybe that benefit will also come back to the customers. Because end of the day, anything you spend less, it is good not for NMDC, it is also good for the country. So what is that your thought about mining as a, as an industry, if I have to look at? What are the different things that NMDC is trying to explore and will be doing in future?
As the earlier speakers, Sir Sundaraman and even DB sir has said, mining is the industry which has the disadvantage that if you want to increase your production, it contributes to environment pollution. If you want to add value to your product, it adds to the cost. Again, it falls on the steel. The only thing what we are looking at is capacity building of our in-house geology team, who have conceptualized the ore body modeling, the mine planning, and the exploitation. Modification of our crushing and screening plants, which definitely guide us to the quality and the quantity of production. Because if you have in-house capacity building, that comes with less cost. That is one of the big things that we are doing. Even today, one of our team members are at Russia, studying how the Russians do their mining, how do they explore, how do they do sustainable mining. NMDC is one of the initial companies who has been talking about sustainable mining, and not to sacrifice the removal of ore burden. We also do waste mining regularly so that quality ore is maintained. There is a mix of wind and solar energy which we were using for a decade now. We had sensed the need of sustainability and holding on to the environment because our mines are deep in the Naxal prone areas, the remote areas of Baladela and Dhonimalai. Without giving your best to your stakeholders and to the environment, you cannot sustain. And there is a huge capex announced by our company of more than 30K crores, which will be visible to the whole world. We are benchmarking ourselves to the international standards. And we would like to say that as today our people are going to the world and seeing other mines, we would see people coming from other world and visiting India to see the sustainable mining practices of our country also. Thank you.
Thank you. Very well said, ma'am. So coming back to Vinodji, sustainability is something like I use coin three letters, so to say: reduce, reuse, and recycle. I think that's also a major part of sustainability. Sustainability is not about technological development or bringing new technologies. So in that area, even if I look at ferroalloys, we have byproducts which are also quite significant. And for every ton of ferroalloys, we produce somewhere between 600 to maybe 700, 800 kilos of slag we generate. So what according to you, that what is will be the best utilization of this slag, which is considered to be a waste today? One is that it takes a lot of space in the premise, and also it is very unsafe to have that material inside the plant. So you have done a lot of work, I guess, for many years now, that how do you really utilize this slag which is being generated not only from ferroalloys, even from the steel plants also? Because you have must have done a lot of work around it.
This is a very interesting subject, utilization of the waste. In fact, every plant, whether it is metallurgical or other processing plant, they produce some kind of waste. Now, ferroalloys waste, especially the ferrochrome, if we see metallurgically, it can be of no use. It has to be used in some industry where it can replace a similar material. To my knowledge, what we have done with this kind of waste is creating building material like your blocks and bricks, which can be used along with fly ash. And fly ash also will have a very good effect on sustainability, because once the wastage is utilized, and second is what we are not talking of today. Since morning we are discussing about CO2, and it is supposed to be the only villain which is increasing the temperature of the earth. I don't think that it is the only thing which is increasing the temperature. It is also the albedo. We are not talking about the albedo of concrete, albedo of the roads we are building. NHI is every year creating 3,000, 5,000 kilometers of roads, and they have a very low albedo. So the temperature rise is not because of only CO2. So this will be one of the area where it can be used. Second, I'll give one reply to Deepak ji's very interesting point, that DRI industry में हम लोग काम कर रहे हैं, but DRI industry में very less innovation has been done. Like norms are fixed. आपने इतना टन आयरन ओर लिया, इतना टन कोल लिया, आपका स्पॉन्ज आयरन बन गया, इतना डोलोमाइट डाला. आपने पेलेट लिया, इतना ओर लिया, हमने इतना बनाया, ये माल निकलता है, इतना मेटलाइजेशन आ गया, वी आर हैप्पी विद दैट. बट टुडे देयर इज अ लॉट ऑफ गैप इन दैट. That gap is, number one, the carbon we are using there, is it optimum? Is it more? Is it less? And if we do on the study on the dissolution of the carbon, we will find that lot of coal can be saved. We did some experiments at Tata Steel, and we found that up to 12% of the coal can be saved in the DRI making process if it is done very judiciously, and if you can use certain specialty additives. So it is possible to do that. Lot of CO2 will be saved in that way. On west side, I'll give you some deeper analysis. We took a project from NTPC for utilization of their fly ash, which was from the super thermal power plants. Now we all think that fly ash is same from all the power plants. It is not. Super thermal power plants, they create a ash, the fly ash, which is almost 100% minus 325 mesh. It is like a talcum powder, and binding that is very difficult with a normal process. Now this kind of material, if it is combined with slag, ferroalloy slag, then it can be a very good like source for a very good quality raw material, because the slag is very hard, and if you use up to 30 to 40% in the bricks, that will be very good. And you can produce blocks also, and produce something new blocks like interlocking blocks. If we make interlocking blocks, no cement is used in joining also. So one way you save carbon footprints on this cement use also, and then you can make an innovative material also. Thank you, sir.
So I think the last point again, we'll come back to Deepak ji on a different subject is, जो अभी, we started with 200 million, 300 million tons of steel, and obviously when we produce that much of steel, you also need that much of ferroalloys also, because ferroalloys or manganese alloys or ferrochrome is something like backbone of the steel making also. So going forward, little commercial question, but going forward, just say, India is the largest exporter of manganese alloys today, and as India's own requirement will go up. So what do you think that India's role in the manganese alloys exports going forward? Because as India consumes more, India have less material to export, which is in some sense good for the industry, or in some sense, I would say that is there an opportunity for Indian producers also to grow, because if there's opportunity going forward. Usme, what do you think, Deepak ji, in terms of manganese alloys? Since you are the only producers who is present in both steel and ferroalloys. That's what that question is.
थैंक यू. एक्चुअली ये इंडिया फेरोलाई का बहुत बड़ा एक्सपोर्टर है, और हम लोग मैग्नीज ओर जो है बाहर से लेके आ रहे हैं, इम्पोर्ट कर रहे हैं. अगर मैग्नीज ओर की जो प्रॉपर्टी जो है अगर उड़ीसा के अंदर में या साउथ के अंदर में कहीं पे अगर हमें मिल जाती है, तो हमारा कॉस्ट ऑफ प्रोडक्शन भी काफ़ी कम हो जाएगा, क्योंकि हमको इंपोर्ट नहीं करना पड़े, कम से कम इंपोर्ट करना पड़े, तो हम ज़्यादा एक्सपोर्ट कर सकते हैं. और फेरोलाई के लिए चीप पावर की ज़रूरत पड़ती है. पावर का अगर कॉस्ट हमारा कम हो जाए किसी भी रूप में, या तो हम अपना पावर प्लांट बना लें या गवर्नमेंट जो है हमें पावर चीप रेट में दे दे, तो फेरोलाई यूनिट के लिए बहुत ही गोल्डन अपॉर्चुनिटी रहेगी, और हम लोग इसके अंदर में ज़्यादा प्रोडक्शन कर सके, प्रोडक्शन बढ़ा के जो है एक्सपोर्ट भी कर सकते हैं, और डोमेस्टिक डिमांड जो बढ़ रही है उसको भी मीटअप कर सकते हैं.
Thank you. I think we have, if I have to summarize, I would say in 3 words that what we discussed so far. I think, ma'am, from your point of view, I think it's got up, I would say that everybody is inside the room who is a steel producer has got a lot of assurance listening from you that NMDC is going to produce 100 million tons in different forms. I think you are also looking at beneficiating, you are also looking at pelletizations. I think what is more, I would say, overwhelming to know that when you said that somebody would come from the external world to see the mines, and they say that it's also make in India in some sense. Okay, so I think best wishes for taking that journey forward. I think what is from Binodji's point of view that probably India has not done enough. I think what Devashish sir was also in the morning, we are discussing that if as a country we are dependent on everything. So to be very honest, from a technology to the materials, then it's like tap on and tap off, and that's what we can observe. That if you want to do a EV, India has a plan to produce about 1 million ton of EVs in next 2-3 years from current of 250,000 tons, 250,000 cars that we have sold last year. So I think as an industry, we need to really ponder, need to introspect that what is that we are going to do if we want to be a, nation which is self-sustaining, because we are still dependent too much on many raw materials that we are bringing in from outside, and also the technology for it. But nevertheless, 2010, 2020 and 2030 will not be the same. So more probably this is now India's turn, I would say, that how do we take this country forward with development of new technologies, and also looking at different raw materials that is required for technological development. With this, we will conclude, and thank you all the panelists for your points towards industrial growth and how do we make the industry more sustainable. Thank you very much.
For conducting this very well thought panelist. May I now request, I think, Dr. Orgo Majumdar, please come and do the honor for giving a token of appreciation from you. And thereafter, we'll just have a photograph and then session photograph, and I'll do. Thank you, ma'am. Thank you. अरे सेशन चेयर के दिते হবে হ্যাঁ ডবল দিতে হবে রাইট তুমি ঠিক বলেছো ইউ আর অ্যাবসলিউটলি রাইট আমি ঠিক and we'll have together photo দিয়ে দাও একশো দিয়ে দাও আরেকটা দিও না one more we'll have it together. Please, we'll have it together. Please stand.